Welcome to video lesson 7 of Unit 6B. Once again, no reading to go along with this video. We are going to be talking about graphing polar equations by hand, and this is just a mini lesson to get you ready for the group work we're going to be doing in the next class. How to graph polar equations by hand. In this video, we're going to be graphing r equals 5 times sine of 3 theta. The first thing that I'm going to do is I'm going to make a table of values so that we can graph points of this particular equation. I've broken it down because finding 5 sine of 3 theta in your head, not so easy. So we're going to break it down and first multiply the theta by 3, then put it into sine, and then multiply by 5. And yes, you will be doing this tomorrow. 3 times 0 is 0, 3 times pi over 6 is 3 pi over 6, but you must reduce. 3 pi over 6 is pi over 2. 3 pi over 4s, that's just 3 pi over 4. 3 pi over 3 is pi. 3 pi over 2, that doesn't reduce. 3 times 2 pi over 3 is 6 pi over 3, or just 2 pi. 3 times 3 pi over 4 is 9 pi over 4. 3 times 5 pi over 6 will reduce to 5 pi over 2, and 3 pi is just 3 pi. So that was just multiplication. But it's necessary multiplication, and you really do need to know how to reduce these, otherwise the next column gets much trickier. Sine of 0. We're taking sine of the second column now. Sine of 0 is 0. If you will remember, this was one of the quadrantals because it wasn't something where you could make your special right triangle like you could with, say, 3 pi over 4. We're going to have a lot of quadrantals now. Remember, sine is the vertical, sine is y. So we're going to remember that when we've gone 0 for our theta, we haven't gone up or down any, so sine is 0. Cosine, remember, would be 1. For the next one, we have sine of pi over 2. Pi over 2 is 90 degrees. Hey, on our unit circle, we would have gone up 1. By the way, this right here is our unit circle. It's kind of tiny, but it's still a unit circle. So we've gone up 1. For 3 pi over 4, 3 pi over 4 is, here's pi over 4, pi over 4 is here. Your 45-degree angles are right in between your 30 and 60, so in case you've forgotten that. So that's 3 pi over 4. If you remember correctly, that creates a 45-degree angle with your for your reference angle. So you have 1, 1, and the square root of 2. So this is going to be, sine is positive, going up, positive root 2 over 2. I want you to pause and try and fill in the rest of this column using your knowledge from last semester. All right, pause it. I'll wait for you. Oh, you're back. Oh, good. Let's see if you got those right. One of the things I want you to remember is that this was negative 1, not just 1, because 3 pi over 2, you're going down 1 for sine. And then 5 pi over 2, when we get here, we've gone beyond a full rotation. So remember 9 pi over 4, that's 1 pi over 4, 2, 3, 4, 5, 6, 7, 8 pi over 4s, and then another to get to 9 pi over 4. 5 pi over 2 is 1, 2, 3, 4, 5 quarters. So you get right back to pi over 2. These are going to be coterminal with, say, purple. Coterminal with pi over 4. This is coterminal with pi over 2. This is coterminal with pi. Remember, they're just 2 pi away from each other. Alright, last step is just plain multiplication. And that's actually really easy. 0 times 5 is 0, 0 times 1 is 5, 0 times 2 pi over 2 is 5 2 pi over 2's, etc. Now the idea is we are going to be graphing, focusing on these two columns. So let's start with our first coordinate, 0, 0. Well, that's easy enough. Start at 0, having gone around 0 amount. Now, on the pi over 6, we're going out 5. So we are going to go find pi over 6, and we're going to go out 5. 1, 2, 3, 4, 5. For pi over 4, that's here, we're going to go out 5 root 2 over 2, which when I put it in my handy-dandy calculator, I got approximately 3.54, so around 3.5. 1, 2, 3.5, a little more than that. 0, back to 0. So at pi over 3, I go out 0. At pi over 2, I'm going negative 1. So this is my pi over 2 line. I'm going to go negative 1, oh sorry, negative 5, 2, 3, 4, 5. So remember, this is my pi over 2 coordinate. It was just negative. Now I go to 2 pi over 3. That's here. And I'm going to be going out 0. My 3 pi over 4, I'm going to go out my 3.5 again. 1, 2, 3.5. For 5 pi over 6, I'm going out 5 again. And for pi, I'm going out 0. Now, two quick things that I want you to note here. I have a bunch of points. How on earth am I supposed to connect them? The other thing I want you to note is that I'm missing a lot of points in between. Like, I didn't do anything on my pi over 12. I didn't do anything at any of these places that are in between here. So there are going to be some missing coordinates even within the every 12th of pi. So I'm going to just let you know that there's going to be some symmetry here. If I had graphed at pi over 12, it would have been here. If I had graphed at, let's see, that's going to be 1, 2, 3, 4, 5 pi over 12, I would have gotten negative 5 root 2 over 2, which would have been 1, 2, 3.5 here. 7 pi over 2 would have been also negative. So I'm just kind of letting you know as FYI, this would also have created that symmetry. It's still a whole bunch of points and you're not quite sure how to connect them. So the main focus point that I want you to think about is that when you have these, you want to connect in order. If you don't pay attention to the order, it'll look like, well, I can do a line across here and a line across here. And no, that's not what I'm doing. I started at 0, 0. And then I went out to 5. So there's my arrow of the direction I graphed in. And then I went here. So I'm going to go over here. And I'm going to put a little arrow reminding myself that's the direction I graphed in. I went right back to 0 when I was at pi over 3. So as I get closer to the line pi over 3, I'm getting closer to 0. From there, my curve continues because the next one I graphed was negative 5 at pi over 2. So I'm going to continue my curve to try and get to pi over 2 and loop around back to 2 pi over 3, 0. From here, so this was out and back, from here I can continue my loop to my 3 pi over 4 and 5 2 pi over 2's. Sorry, that was a typo. That's better. taking you out and back in to pi 0, 0. So now that I have this, and I know we have to connect in order, I just want to let you know what we're planning to do with all of this. In our next class, you are going to be working on a perfect problem very similar to what I just showed you, only going from 0 to 2 pi, not just to pi. You're going to be graphing these and putting them up to show others, and then comparing all of the different types, transformations of polar trig graphs, because you know that like adding makes it go up or down in rectangular trig graphs, but how do polar trig graphs change when like you go from sine of theta to sine of 2 theta, or from sine of theta to 5 sine of theta, or 1 plus 5 sine of theta? How do those change? So we're going to be exploring that in class tomorrow. I hope that you were able to follow along today and get this lovely graph so that you'll be ready to go for our groups tomorrow. Practice your special triangles.